Welcome to this tutorial on string arrays in NumPy. In this video, we'll explore how to work with string data types in NumPy arrays. String arrays are a powerful feature that allows you to handle text data efficiently within the NumPy framework. Whether you're working with datasets containing names, categories, or any other text-based information, understanding string arrays will be essential for your data analysis journey. String arrays allow you to store sequences of characters, or text data, efficiently within NumPy arrays. They're particularly useful when working with structured data, such as table columns containing names, categories, or labels. You might also use them for text features in machine learning applications. The key advantage is that string arrays enable fast, vectorized operations on text data, meaning you can perform operations on entire arrays at once rather than looping through individual elements. Creating a string array in NumPy is straightforward. First, import numpy as np. Then, use the np.array function with a list of strings. For example, we can create an array containing the strings apple, banana, and cherry. When you check the data type using r.dtype, you'll see it returns something like less than U6. This is NumPy's way of indicating that you have a Unicode string array with a maximum length of 6 characters. Let's break down what less than U6 means. The less than U part indicates that this is a Unicode string type, which supports international characters and symbols. The number 6 represents the maximum string length in characters. This is important because NumPy uses fixed-size arrays for efficiency. All strings in the array are padded to the same length, which allows for fast memory access and vectorized operations. NumPy automatically determines this length based on the longest string in your array. You can explicitly control the maximum string length when creating your array. By specifying dtype equals U10, you're telling NumPy to allocate space for strings up to 10 characters long. In this example, we create an array with apple, banana, and kiwi and set the dtype to U10. When you check the dtype, it confirms that the array now uses U10 as its data type. This is useful when you know you might add longer strings later, or when you want to ensure consistency across multiple arrays. NumPy provides a special module called np.char that contains many useful string operations. Let's say you have an array of fruit names. To convert all strings to uppercase, use np.char.upper and pass in your array. This returns a new array with all strings in uppercase. To get the length of each string, use np.char.str_len. This returns an array of integers representing the length of each string. These operations are vectorized, meaning they're applied to all elements at once, making them very efficient. You can concatenate or combine strings from 2 arrays using np.char.add. For example, if you have one array containing hello and good, and another array containing world and morning, using np.char.add will combine corresponding elements. The result would be an array with hello world and good morning. Notice that there's no space added automatically between the strings, so you'll need to add spaces manually if you want them in your concatenated result. Comparing strings in NumPy arrays is simple and efficient. Let's say you have an array of animal names: cat, dog, cat, and bird. To find which elements equal cat, you can use a standard comparison operator. Simply write words double equals cat. This returns a Boolean array with true where the string matches and false where it doesn't. In this case, you'd get true, false, false. You can then use this Boolean array for filtering or counting matching elements. The np.char.split function allows you to split strings in your array based on a delimiter. By default, it splits on whitespace. For example, if you have an array containing hello world and numpy arrays, calling np.char.split will split each string at the space character. The result is an array of lists, where each list contains the split words. So you'd get a list containing hello and world, and another list containing numpy and arrays. This is particularly useful for text preprocessing tasks. Let's recap what we've learned. String arrays enable efficient text processing in NumPy by allowing you to store and manipulate text data using vectorized operations. The np.char module provides a wide range of functions for working with strings, including case conversion, concatenation, splitting, and comparison operations. Remember to specify an appropriate dtype for your string lengths to avoid truncation. With these tools, you're now equipped to handle text data effectively in your NumPy projects. Thank you for watching, and happy coding!
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.